The Birth of Stars and the Creation of Elements. Title: The Birth of Stars and the Creation of Elements. Introduction. The vastness of our universe holds many mysteries, among them the awe-inspiring process of star formation and the subsequent creation of elements. Stars, the celestial powerhouses of light and energy, are born from the interplay of gravity, gas, and dust in vast stellar nurseries. Over billions of years, this process has not only shaped the cosmic landscape but has also given rise to the elements that form the building blocks of life. In this article, we will explore the fascinating journey of star birth and its profound impact on the creation of the elements we know today. Stellar nurseries, the cradles of creation. Stars are born in gigantic clouds of gas and dust known as stellar nurseries or molecular clouds. These nebulous regions, often stretching across several light-years, serve as the cosmic cradles for the birth of new stars. Gravity plays a crucial role in triggering the collapse of these dense regions, initiating the process of star formation. Under the relentless force of gravity, the molecular cloud begins to collapse upon itself. As the cloud shrinks, it fragments into smaller pockets of gas and dust. These clumps, known as protostars, continue to accrete matter from their surroundings, gradually growing in size and mass. Protostellar evolution, the making of a star. As the matter continues to accrete onto the protostar, it heats up, eventually reaching a critical temperature and density at its core. Once this critical threshold is crossed, the process of nuclear fusion is initiated. The primary fusion reaction occurring in most stars is the conversion of hydrogen into helium, which releases an enormous amount of energy in the form of light and heat. Main sequence stars, the stellar forge. Once a protostar's core reaches a temperature and pressure at which nuclear fusion sustains itself, it officially becomes a main sequence star. This turbulent dance between opposing forces allows main sequence stars to shine brilliantly, radiating energy into space. The birth of elements, stellar nucleosynthesis. While main sequence stars commonly fuse hydrogen into helium, they are also capable of synthesizing heavier elements. As a star evolves, it gradually exhausts its core fuel, leading to changes in its internal structure. For stars more massive than our Sun, this leads to the fusion of helium into heavier elements such as carbon, oxygen, nitrogen, and so forth. As the star approaches the end of its life, it may undergo a massive explosion known as a supernova. During this cataclysmic event, the core of the star collapses under its own gravity, rebounding in a tremendous explosion that releases an enormous amount of energy. These violent explosions are responsible for the creation of elements beyond helium, including those essential for life, such as carbon, oxygen, and iron. The journey of star birth and the creation of elements is one of the most fascinating processes in our universe. Stars, which are the powerhouses of light and energy, are formed through the interplay of gravity, gas, and dust in stellar nurseries. These stellar nurseries, also known as molecular clouds, are vast clouds of gas and dust spread across several light-years. Within these clouds, gravity triggers the collapse of the dense regions, initiating the formation of new stars. As the molecular cloud collapses under the force of gravity, it starts to fragment into smaller pockets of gas and dust called protostars. These protostars continue to accrete matter from their surroundings, gradually increasing in size and mass. The evolution of a protostar involves a complex interplay of forces, including gravity and the outward pressure generated by the energy released through nuclear fusion. During the protostellar phase, as matter continues to accrete onto the growing star, it heats up and reaches a critical temperature and density at its core. At this point, nuclear fusion is ignited. The primary fusion reaction in most stars is the conversion of hydrogen into helium, which releases an enormous amount of energy in the form of light and heat. Once the core of a protostar reaches a temperature and pressure at which nuclear fusion is sustained, it becomes a main sequence star. Main sequence stars, such as our Sun, spend most of their lives fusing hydrogen into helium in their cores. This delicate equilibrium between gravity and fusion allows main sequence stars to radiate energy and shine brilliantly. While main sequence stars primarily fuse hydrogen into helium, they are also capable of synthesizing heavier elements. As a star evolves and exhausts its core fuel, changes in its internal structure occur. For stars more massive than our Sun, helium fusion into heavier elements like carbon, oxygen, and nitrogen takes place. Eventually, stars may reach the end of their lives and undergo a massive explosion known as a supernova. During a supernova, the star's core collapses under its own gravity and rebounds in a tremendous explosion, releasing an enormous amount of energy. These explosive events are responsible for the creation of elements beyond helium, including those essential for life, such as carbon, oxygen, and iron. In addition to supernovae, stellar remnants like neutron stars and black holes witness other processes like neutron capture and our process nucleosynthesis. These processes occur under extreme temperatures and pressures and are responsible for the formation of heavy elements like gold, platinum, and uranium. The birth of stars and the subsequent creation of elements not only reveal the immense forces at work in our universe but also constitute the very foundation of our existence. The elements forged within stellar furnaces are the fundamental components of every atom in our bodies and every piece of matter on Earth. The intricate interplay between gravity, temperature, and pressure has crafted the cosmic tapestry of life as we know it. Studying the captivating story of star birth and the creation of elements allows us to deepen our understanding of our place in the universe. We are all interconnected with the cosmos, formed from stardust and forever part of the grand symphony of creation. The journey of star birth and the creation of elements is an incredibly fascinating process that shapes our universe. Stars, which are celestial powerhouses of light and energy, are born from the interplay of gravity, gas, and dust in vast stellar nurseries. These stellar nurseries, often referred to as molecular clouds, are massive clouds of gas and dust that stretch across several light years. Within these clouds, the force of gravity triggers the collapse of dense regions, initiating the formation of new stars. As the molecular cloud collapses under the force of gravity, it fragments into smaller pockets of gas and dust known as protostars. These protostars continue to accumulate matter from their surroundings, progressively growing in size and mass.